y equals mx plus b, a very important formula that we can look at and get a lot of information from just by looking at the numbers. So we're going to follow these steps. We're going to plot the y-intercept. And starting at the y-intercept, we're going to use the slope to locate a second point and a third point. We want to connect these points and extend the line in both directions. Okay, so the y-intercept is the value of b, and in this case, it is -5. So let's start by plotting that -5 y-intercept. Put it right there. Now, the next bit of information that we can gather from this equation is the slope. And the slope is that coefficient or number that's sitting right in front of x. So this tells us that the slope is 4. Since the slope is 4, means that for every unit that we travel along the x-axis, following the animation of the green line, we're going to travel up 4 along the y-axis. And when we arrive at this point, we can add another coordinate and then do the same thing again. 1 along the x-axis, 4 up the y-axis, plot the coordinate point again, join the lines, and there's our graph for y equals 4x minus 5. Now we're not reading any table of values. All we're doing is just gathering the fact that this number right here, the b value in y equals mx plus b, is -5, which is a y-intercept, and 4, the coefficient in front of x, is our slope, or m. Y equals -x plus 3. Looking at the value of b tells us what the y-intercept is. So we can plot that. In this case, it's 3. So we'll just put a coordinate point at the y-intercept where at 3. Now looking at the coefficient in front of the x value, it's presumed to be -1. It's not actually written there, but we assume that there's a -1. That means that we can move across the x-axis 1 point and move down the y-axis 1 point. It's -1, so we'll be moving. We arrive at that point. We can plot that second coordinate, then start again. Move 1 across the x-axis, down 1 along the y-axis, plot that point, connect the lines, and then we have our graph for y equals -x plus 3. Here we're given y equals 2/5 x plus 3. Using our y equals mx plus b formula, our b value is 3. So we can plot that, put that right as the y-intercept. And our slope will be the coefficient in front of the x, which is 2/5, which tells us that for every 5 units across the x-axis, we'll move up 2 units along the y. We can plot that point and do the same again. 5 across, 2 up, plot the point, connect the dots, or connect the points, and then we have our graph for y equals 2/5 x plus 3. Write the equation of each line in y equals mx plus b form using the information given. Well, for a, we're told the slope is 7 and the y-intercept, or b, is 9. So we can simply write y equals 7x plus 9. B, we're told that m is -3 and b is 3. M is just the variable we use for slope, so the slope is -3, and the y-intercept, or b, is 3. So there's our equation, y equals -3x plus 3. C, we're told m, or the slope, is 0, and b, or the y-intercept, is -3. So if m is 0, we will not have any value or any coefficient in front of an x. So we can just simply say y equals -3. For D, we're told that the slope is 7/2, and B, or the y-intercept, is 0. So we can say y equals 7/2 x, and because there is no, I shouldn't say there is a y-intercept, but it runs through the origin. So we can simply say y equals 7/2 x plus 0, which would be just the same as 7/2 x. So this is a line that runs right through the origin, or right through the point 0, 0. 0 is where the y-intercept is. And here's what the various graphs will look like. 7x plus 9 is this line right here. This negative slope, -3x plus 3, is right here. This orange line right here, y equals 3. This means that no matter what the x value is, the y value will always be 3. This also means that the slope is 0. There is no coefficient in front of an x value, which is why it's a flat line. There is no slope to it at all. And D, y equals 7/2 x, it has a slope of 7/2, but there is no b value, which is why we see the y-intercept being right at the point 0, right through the origin. Determine the slope and y-intercept for each of the following. Use the information to graph each line on the same xy plane. Label each line. Well, in A, m is simply the number in front of the x, or the more proper way of saying that is 4 is the coefficient, or the x coefficient. And the b value is -5, or the y-intercept. B, the slope is -1, and the y-intercept, or b value, is 6. the coefficient of c, the coefficient of the x value, is 2, and the y-intercept is 0. So once again, this graph will pass right through the origin. And d, the slope is -1/2, so m is -1/2, and the b value, or y-intercept, is -2. And we put all these graphs on the same xy plane. Once again, you can see for graph C, y equals 2x, there is no b value, which tells us that the y-intercept is right through the origin at 0. Question 6, y equals 2/3 x minus 2. Our y-intercept, or b value, is -2. So we'll plot that point right there. And our slope is 2/3, which tells us that for every run of 3, there will be a rise of 2. We can plot that point. A run of 3, rise of 2, plot that point, put a line through it, and there's our graph for the equation y equals 2x minus 2, with a slope of 2/3 x and a y-intercept of -2. Y equals 2x minus 4. Our y-intercept is -4, so we can plot that. And we're told that our slope is 2. So starting from the y-intercept, we can run of 1, rise of 2. And then we arrive at a point that we can plot. Run of 1, rise of 2. Plot that point. Connect the coordinates. And that's what our graph of 2x minus 4 looks like, with a slope of a slope of 2 and a y-intercept of -4. It's important to understand that the slope is 2. Often students will make the mistake of saying that the slope is 2x. That is not correct to say. The slope is the number that's the coefficient of x. It's the 2. It is not 2x. Part C, y equals -3/2 x plus 5. Our b value, or y-intercept, is 5, which we'll plot. Now, with a slope of -3/2, we'll start at the y-intercept with a run of 2 and a rise of -3. Arriving at this point, we'll plot that and do the same again. A run of 2, a rise of -3, plot the point that we arrive at, draw a line through the 3 points, and this is what our graph of -3/2 x plus 5 equals. This is what it looks like. Our slope's -3/5. Our slope is -3/2, and our y-intercept is 5. Next question gives us an equation of y equals -5x plus 2. Our b value, or y-intercept, is 2. We'll plot that. And now, starting from this point, we see that we have a slope of -5. So for every 1 unit over, we'll go down 5 units. Plot the point. Over 1 unit, down 5. Plot the point. Connect the coordinates. And this is what the graph y equals -5x plus 2 looks like, with a slope of -5 and a y-intercept of +2. Now, I have made a mistake on this. In the previous question, I made note of the fact that a slope is not -5x. It is just the coefficient in front of the x. So as this is written right now, I've written it wrong. So let's ignore the x. The slope is actually -5. Question 7, y equals -16x plus 8. Our y-intercept, or b value, is 8, which we'll plot. And our slope is -1/6. So for every 6 units that we head across the x-axis, we'll go down 1 unit. We'll plot the point that we arrived at and do that again. A run of 6, a rise of -1, plot the point, connect the coordinates. So our graph of y equals -16x plus 8 looks like that. Our slope is -1/6. Our y-intercept is 8. 2. Our b value, or y-intercept, is 2. So we'll plot that. And our slope is 3/4. So we'll start with a run of 4 and a rise of 3. Plot that point. Run of 4 again, a rise of 3. Plot the point. Connect the coordinates. And this is what the graph of 3/4 x plus 2 looks like, with a slope of 3/4 and a y-intercept of 2. Here we have y equals -6 plus 2/5 x. Now, this is not, technically speaking, in y equals mx plus b form. We want to see the term that has the x value right to the right of the equal sign. So we're going to rewrite that y equals -6 plus 2/5 x. We'll rewrite that as y equals 2/5 x minus 6. Just more conventional. Now, our b value, or y-intercept, is -6. Plotting that point, our slope is 2/5. So for every run of 5, we go up 2. Plot the point that we arrived at. Run of 5, rise of 2. Plot the point we arrive at. Connect the coordinates. This is the graph, y equals 2/5 x minus 6, with a slope of 2/5 and a y-intercept of -6. Here we're given the equation y equals -x. Now there is no b value, or probably more correct to say the value of b is 0. So our y-intercept is going to be right at the origin, 0, 0. Now with a slope of, or the coefficient of x is negative, or -1. So our run will be 1 and our rise will be -1. We'll plot this point. Run of 1 again, rise of -1. Collect the points, or rather draw a line through the points. And there is our graph, y equals -x. The slope is -1. The y-intercept is 0, which once again is why this graph is running through the origin. Y equals -4/5 x plus 9, and y equals 3/5 x plus 2. So in question 8, we're given two equations and asked to plot and graph these two equations on the same xy plane, or Cartesian plane. So we'll start with the first one. Our b value, or y-intercept, is 9. And for the second equation, our y-intercept is 2. So for the first equation, the slope's -4/5 and the y-intercept is 9. For the second equation, the slope's 3/5 and the y-intercept is 2. We can plot the two y-intercepts, and then we can start looking at their respective slopes. So the slope for the first equation is -4/5. So here's a run of 5 and a rise of -4. A run of 5 and a rise of -4. Once we have these coordinates plotted, we can connect the 3 points with a line. So our blue line represents y equals -4/5 x plus 9. Now, looking at the second equation, y equals 3/5 x plus 2, we'll start at the y-intercept, which is 2. We'll have a run of 5 and a rise of 3. A run of 5 and a rise of 3. We'll put in our coordinate points, connect those points with a line, and this is what the graph of y equals 3/5 x plus 2 equals, or looks like. The point of intersection is where these two lines cross, and you can see that this point is right here at the coordinates 5, 5.